Now that we've learned about prime factorization, we're going to look at prime factorization in relation to greatest common factor and least common multiple. So first, let's just remind ourselves of how we found the greatest common factors and least common multiples before. Okay, so using the example from 4.2, when we wanted to find the greatest common factor of 8 and 12, we listed all the factors of 8, listed all the factors of 12, then found the largest factor they had in common, which was 4. Okay, so this can be a little bit tedious, and these aren't even really big numbers. So when they're bigger numbers, you could have factor lists that go on for a while. Okay, to find the least common multiple, we said we can list some multiples of 8, list some multiples of 12, till eventually we see one that matches up. Okay, we had 48 and 24. The smallest multiple they have in common is 24. Okay, so this is the method we used before, and this is okay when you have smaller numbers, but when you have larger numbers, listing multiples and listing factors can be really tedious. So we're going to look at a method of using the prime factorization to determine the GCF of two numbers. So first we're going to do this with 8 and 12 and verify that our results correspond. And then we're going to look at some larger numbers. So first, let's find the prime factorization of 8. 8 is 2 times 4. 2 is prime. 4 is 2 times 2. So now we have 3 factors of 2. So 2 times 2 times 2. And I'm just going to write that in factored form. For 12, we would have 3 times 4. 3 is prime. 4 we need to keep factoring. It's 2 times 2. And in factored form, we have 2 times 2 times 3. Okay. Now we're going to create a list of common prime factors. Okay, so what do they have in common? And notice it says include repeated factors. So they each have 1, 2, but they each have 2 factors of 2. So let's list those. And that's all they have in common. So 8 has 3 factors of 2, but 12 does not have a third factor. Now the greatest common factor is the product of these common factors. So 2 times 2 is 4. And this corresponds with our previous result. So when we have them down in this prime factored form, it's easier to identify their greatest common factor because there's no more, we can't break down the factors anymore. These are broken down into primes, so there couldn't be a hidden factor in a number that we're not recognizing. Now here's a really nice result. The least common multiple of 8 and 12 is their product divided by their GCF. Okay? So find the least common multiple. So the product of 8 and 12, 8 times 12, divided by their GCF. So 8 times 12 equals 96 divided by 4 equals 24. Okay, and this corresponds with the result we found before. Okay, so there's another way to use the prime factorization to find the least common multiple, but it's a lot easier or a lot more direct just to do this multiplication of the two numbers and divide by the greatest common factor. So now let's do this for a problem that you'd really want to use this method for. Okay, so use the prime factorization method to determine the GCF and LCM of 54 and 90. So imagine listing these multiples. Okay, we'd have 54, 108, adding 54 would be 162. I mean, this would not be fun. Okay, 90 isn't as bad, but we'd have to keep listing them till they match up, and this could take a while. Okay, so for numbers like these, we'd really want to use this method. So let's find the prime factorization of 54. Okay, the first factors that I think of are 9 times 6. Okay. And you could also divide by 2 because it's even if you don't remember this number fact, and the numbers will keep getting smaller and it'll be easier to factor. So notice these numbers are smaller than 54. Since you're factoring it, you're breaking it down. 9 is 3 times 3, and 6 is 2 times 3. Okay. So the factored form of 54, I'll write these in increasing order, is 2 times 3 factors of 3. Now let's look at 90. The first factors that come to mind for me are 9 times 10. 9 is 3 times 3, and 10 is 2 times 5. And all of these are prime, so their product in increasing order is the prime factorization of 90. 2 times 2 factors of 3 times 5. Okay. Now let's make a list of the common prime factors. Remember, always include repeated factors, the most they have in common. Well, they each have 1, 2. Okay. 54 has 3 factors of 3. 90 has 2, so the smaller amount is what they have in common. So they each have 2 factors of 3. This has another factor of 3, but this one doesn't. This one has a 5, but this doesn't. So this product, or these common factors, their product is going to be our GCF. So the GCF of these two numbers is 2 times 3 times 3, which is 6 times 3, which is 18. Okay, so imagine if you had to make these factor lists, this would take a while. Now let's find the LCM. Well, if we take the product of the numbers 54 and 90, that means multiply them, and then divide by the GCF, 18, we will have the LCM. So let's do this on the calculator. 54 times 90 equals 4860, divided by 18 equals 270. Okay, so that's a pretty big least common multiple. We would have had to list 2 more multiples in this list just to get to that, and it would be a little bit tedious. So we got that relatively quickly by using this method. To review, find the prime factorization, find the common factors. The product of the common factors is the GCF. The LCM can then just be found by multiplying the two numbers you're given and dividing by the greatest common factor.